Students, in this video we are going to see linear combination. Linear combination. Let us see definition of this linear combination. Definition is given vector u1 bar, comma, u2 bar and so on up to uk bar in Rn and scalar alpha 1 comma alpha 2 and so on up to alpha k. The vector u bar defined by u bar is equal to alpha 1 u1 bar plus alpha 2 u2 bar plus and so on up to plus alpha k into uk bar. It's called a linear combination of u1 bar comma u2 bar and so on up to uk bar with weight or scalar alpha 1, alpha 2 and so on up to alpha k. Okay. See here what is linear combination. Given vectors u1 bar, u2 bar and so on up to uk bar in Rn and scalars alpha 1, alpha 2 and so on up to alpha k. The vector u bar defined by u bar is equal to alpha 1 into u1 bar plus alpha 2 into u2 bar plus and so on up to alpha k into uk bar is called a linear combination of u1 bar, u2 bar and so on up to uk bar with weights or scalars alpha 1, comma alpha 2 and so on up to alpha k. Means when u bar is expressed in this form, then u bar is called as linear combinations of u1 bar, u2 bar and so on up to uk bar with scalars alpha 1, alpha 2 and so on up to alpha k. Okay. Let us write down one note here. The weight or scalar in linear combination can be any real number. Students, always remember that scalars in linear combinations are nothing but any real numbers. Okay, means scalars are 1, 2, 1 by 2, root of 3 and so on. Okay. We will see one example of here linear combination. Example 1. Let v is equal to vector 3, 7, minus 4 in R3. Okay. Expressed v in the linear combination of u1 is equal to 1, 2, 3 u2 is equal to 2, 3, 7 and u3 is equal to 3, 5, 6. Student, before solving this example, in bracket write down one note or alternative definition of linear combination. V is a linear combination. V means when V is belongs to Rn is a linear combination of u1 comma u2 and so on up to un if there is a solution to the vector equation v is equal to x1 u1 plus x2 u2 plus and so on plus xn un. Means it is very simple that V is a linear combination of u1, u2 and so on up to un if there is a solution to the vector equation V is equal to x1 u1 plus x2 u2 plus and so on plus xn un. Okay. Now we have to express V as a linear combination of u1, u2 and u3. Okay. Therefore, for any scalar x comma y comma z such that V is equal to, we have to express V in linear combination of u1, u2, u3. Means it is nothing but u1 into x plus u2 into y plus u3 into z. Go by definition of linear combination. This is nothing but what is, put the values of these vectors u, v1, u2, u3. What we get? V is nothing but 3, 7 minus 4, which is equal to u1 is nothing but vector 1, 2, 3 into x plus u2 is nothing but 2, 3, 7 into 1 plus u3 is nothing but 3, 5, 6 into z. Okay. Now we have to solve this system of linear equations. Okay. Which is equal to LHS keep as it is matrix 3, 7 minus 4, which is equal to multiply each entry of u1 by x. What we get? X, 2x, 3x. Okay. Plus 2y, 3y, 7y plus matrix 3z, 5z, 6z. Okay. Which is nothing but what we get? X plus 2y plus 3z. Okay. Next equation is 2x plus 3y plus 5z. Means we have to add these three matrices. Means we have to add corresponding entries. Okay. And last row is 3x plus 7y plus 6z. Okay. See here, these two matrices means this matrix 3, 7 minus 4 and this matrix are equal. Okay. When two matrices are equal, if their corresponding entries are equal, therefore what we get? We get x plus 2y plus 3z is equal to 3. Okay, 2x plus 3y plus 5z is equals to 7. 3x plus 7y plus 6z is equals to minus 4. Okay, now this is a system of linear equation. We have to solve this system of linear equation. Therefore, its augmented matrix A, B, which is nothing but 1, 2, 3, 3, 2, 3, 5, 7, 3, 7, 6, minus 4. Okay, we have to reduce this system to row echelon form. Sorry, this matrix we have to reduce this matrix to row echelon form. Its row echelon form is 1, 2, 3, 3, 0, minus 1, minus 1, 1, 0, 0, minus 4, minus 12. Students, here I will give you one exercise that you have to convert this augmented matrix into this row echelon form. Okay. From this matrix, what we get? We get there is x plus 2y plus 3z is equals to 3 and minus y minus z, because here coefficient of x is 0, which is equals to 1, and minus 4z is equals to minus 12. Okay. Therefore, by back substitution, or here you can say that, here suppose call this equation number 1, this is 2 and this is 3. Equation 3 implies minus 4z is equals to minus 12. That implies z is equals to, here in LHS side 4 is in the form of multiplication. When it goes to RHS, it divides 12. What we get? Therefore 12 divided 4 is 3. That means we get z is equal to 3. Put z is equals to 3 in equation 2. What we get? Minus y minus 3, which is equals to 1. That implies minus y minus 3 is equals to, here is minus y, which is equals to 1 plus 3. That implies y is equals to minus 4. Put value of y and z in equation 1. What we get? If you put value of y and z in equation 1, x plus 2 into y is minus 4, plus 3 into z is nothing but 3, which is equals to 3. Okay, x minus 8 plus 9, which is equals to 3. That implies x plus 1 is equals to 3. That implies x is equals to 2. Thus, here I will write, therefore, what we get? X is equals to 2, y is equals to minus 4 and z is equals to 3. Okay, means in starting we have written that what we have written? V is equal to u1 into x plus u2 into y plus u3 into z. Okay. And what we get? We get solution to this vector equation. We have already write down one note that if you get solution to this type of vector equation, then V is a linear combination of u1, u2, u3. Therefore, V is equal to 2 into u1 minus 4 into u2 plus 3 into u3. Okay. Let us take second example. Let u1 bar is equal to 1 matrix 1 minus 1 0. u2 bar is equal to matrix 0 1 minus 1. u3 bar is equal to matrix, here u3 is not given, and let V bar is equal to matrix 1 2 3. Determine whether V bar can generated or written. Student, don't be confused. Generated or written as a linear combination of u1 bar and u2 bar. Okay, that is determine whether weight alpha 1 and alpha 2 exist such that alpha 1 into u1 bar plus alpha 2 into u2 bar is equal to V bar. If this vector equation has solution, then find out. Okay. In this problem, we have to determine whether V bar is linear combination of u1 bar and u2 bar. Okay. That is, we have to determine whether weight or scalar alpha 1 and alpha 2 exist such that alpha 1 into u1 bar plus alpha 2 into u2 bar is equal to v bar. If this vector equation has a solution, we have to find out this. Okay. Means if this vector equation has a solution, then what happens? V bar is a linear combination of u1 bar and u2 bar. If this vector equation has no solution, then V bar is not a linear combination of u1 bar and u2 bar. Okay. Here what we have given? We have given u1 bar, u2 bar and V bar. Okay. For any scalar for any scalar alpha 1 and alpha 2 such that V bar can be written as alpha 1 u1 bar plus alpha 2 u2 bar. Our n is here. We have to check whether this vector equation has solution or not. Okay. Here V bar is, what is V bar? V bar is matrix 1, 2, 3. Okay. Which is equal to alpha 1 into matrix u1 bar, matrix 1 minus 1, 0 plus alpha 2 into matrix 0, 1 minus 1. Okay. Which is nothing but matrix alpha 1 into 1 means alpha 1 plus alpha 2 into 0 is 0. Okay. Which is nothing but minus 1 into alpha 1 minus alpha 1 plus alpha 2 into 1 is alpha 2. 0 into alpha 1 is 0 and alpha 1 into minus 1 is minus alpha 1. Sorry, here is minus alpha 2. See here, these two matrices are equal, means their corresponding entries must be equal. Therefore, alpha 1 plus 0 is equal to 1 minus alpha 1 plus alpha 2 is equal to 2 and 0 minus alpha 2 is equal to 3. We have to solve this system of linear equation. We solve this system by row reducing the augmented matrix of the system. Okay. We solve this system by row reducing the augmented matrix of system as follows. Okay. Augmented matrix for this system is here two weights alpha 1 and alpha 2 means coefficient of alpha 1 is 1, coefficient of alpha 2 is 0 and constant is 1. Second row is minus 1, 1, 2. Okay. Next row is 0, minus 1, comma 3. Okay. Here we see here in row reducing form, here we require 0 because in row reducing form leading one is only the non-zero element in that column. Therefore here we require 0. Therefore we perform a row operation R2 plus R1. Okay. Then what we get? 1 plus 1. First we keep first row is as it is. What we get? 1, 0, 1. Next, what we perform a operation here? R2 plus R1. 1 minus 1 is 0. 0 plus 1 is 1. 2 plus 1 is 3. 0 minus 1, 3. Okay. In second row, this one is a leading one. Okay. So here we require 0. For this we perform a row operation R3 plus R2. Then what we get? Keep first row as it is. Also keep second row as it is. 0. 0 plus 0 obviously 0. 1 minus 1 is 0. 3 plus 3 is 6. Because here we perform a row operation. 3 plus 3 here is 6. This is your row reducing form, because this is, first of all, this is a row echelon form, and second is only in both the columns, only this leading one and this leading one are the only non-zero element in that column. Okay, therefore or write the corresponding system we get, from this row we get alpha 1 is equals to 1, alpha 2 is equals to 3, and 0 is equals to minus 6. 0 is equals to 6, which is not possible. Therefore, this is not consistent system. Okay. This shows that no scalar alpha 1, alpha 2 exists such that V bar is equal to alpha 1 into U1 bar plus alpha 2 into U2 bar. This shows that no scalar alpha 1, alpha 2 exists such that V bar is equal to alpha 1 into U1 bar plus alpha 2 into U2 bar, or that is V bar is not a linear combination, or here is no need to say that is, or V bar is not a linear combination of U1 bar plus U1 bar comma U2 bar. Or alternative solution for this system of linear equation is, see here, suppose this is equation 1, 2 and this is equation number 3. Okay, from 3 or equation 3 implies minus alpha 2 is equals to 3, that implies alpha 2 is equals to minus 3. Okay, if you put alpha 2 is equals to minus 3 in equation 2, we get, what we get? Minus alpha 1 minus 3, alpha 2 is minus 3, which is equal to 2. That implies minus alpha 1 is equal to 3 plus 2, which is equal to 5. Okay, that implies alpha 1 is equal to minus 5, because here we put alpha 2 is equal to minus 3 in second equation. Then what we get? Minus alpha 1 minus 3 is equal to 2. That implies minus alpha 1 is equal to 3 plus 2, which is equal to 5. That implies alpha 1 is equal to minus 5. But from equation 1, alpha 1 is equal to 1. That means if you put alpha 1 is equal to 1 if you put values of alpha 1 and alpha 2 in equation 2, then we get minus 1 plus alpha 2 is minus 3 which is equals to 2, means minus 4 is equals to 2, means values of alpha 1 and alpha 2 does not satisfy this system of linear equation. Therefore, this system of linear equation has no solution. That is, this system is not consistent. Okay, we will stop here. Thank you.